Okay. So we'll record this.
Recording in progress.
E to the kt is like e to the rt That's from continuous interest. Okay, well, e to the rt is e to the r raised to the t power. So for example, if r equals 0.06, and that would be like 6% interest, and that would be e to the r raised to the t, which is e to the 0.06 raised to the t. And e to the 0.06 is approximately 1.06018. Or is it 1.1618? Now you can check that on your calculator. You can plug that into your calculator and see if I got it right. And it would be 0618. Okay? The lesson of that is
All right, it is 1.061836.
Yeah.
So you were right.
Yeah. And the 36 comes from like a 216 divided by 6, and that's just a coincidence. If it was a 0.07, you wouldn't get a 49 over there. Okay, and that's just, I'm approximating using what's called the Taylor expansion of the exponential function, which is just a polynomial. So I'll just write that down for you. It's something that calculus students in the second semester right now might well be dealing with, or might well have dealt with within the last month. So I'm just going to write this down. E to the x is 1 plus x squared over 2 plus x cubed over 3 times 2. So x to the 4th over 4 times 3 times 2. So the next one would be x to the 5th over 5 times 4 times 3 times 2, and so forth. Okay? So you can easily do the arithmetic and figure out e to the x to as many significant figures as you wish. Okay? Your calculator knows that, even if you don't. But it's actually pretty simple. Now you do need the machinery of first and somewhat second semester calculus, along with intuitions about slopes and rates of change and power functions. This is just a polynomial. It's just that it goes on to infinity. It goes on forever. Okay? So that's, I didn't do any magic to get this. It was pretty easy to square 0.06 and divide by 2, which is where that 1/8 came from. Then if you cube 0.06, you get 0.00000236. I had one too many zeros in that, but or 216, not 236. If you divide that by 6, you get 32. Okay, or 36. I'm sorry, and that's where the 36 came from. Just came from this, and you could plug those numbers in just as easily as I can, but you probably can't do them in your head as easily as I can because I do more of it than you do. Okay. And also I get messed up on the number of zeros because I'm not as careful as I ought to be. Okay, well that's all beside the point. But I thought I'd make that connection because it's one reason polynomials are so important. Now, there should be a then, e to the rt equals. All this means is continuous compounding at 6% is equivalent to yearly compounding at 6.18%. And that's approximately 6.18, 6.1836. And then if you want more than that, right there you can find it. Okay? So generally e to the kt equals e to the k raised to the t which is approximately equal to this raised to the t. And if you take only the first two terms, it's approximately 1 plus k to the t. And that brings us back to the idea that k is your growth rate, or r is your growth rate. And 1 plus k, which is an approximation, is what you call your growth factor. If k is very small, then k squared over 2 is so small you can neglect it. If k is a little bigger, then maybe k cubed over 3 times 2 is so small you can effectively neglect it. But for small values of k, this is a good approximation. For example, if k is 0.06, then using 1.06 is pretty close to being as good as 1.0618. Okay? The 1/8 doesn't make a whole lot of difference. But of course, if it's your investment over a period of 30 years, it does make a significant difference. Okay? If you're trying to model a population, or you're trying to estimate inflation at 6% in the effect of inflation, and it's an estimate, something that you can't work out exactly, then the 1.06 is just as good as a 1.0618. Okay? If it's an investment, that amount will be there. If you're trying to estimate inflation, well, you can't estimate it that closely. You might estimate 6% inflation, but you'd be off by 1%. That 1/5 of a percent there doesn't make any difference. So depending on what you're doing, these approximations can be important. But this also helps you understand what e to the kt means. If k is negative, then 1 plus k will be less than 1, and that'll give you a decreasing exponential. Okay, so there's the connection, and I should have addressed that earlier. I kind of overlooked it, and I kind of didn't notice that the text had used it. Okay, so it's an oversight on my part, but there it is.